All right, here we go. We're going to take a look and go back and kind of review properties of exponents. We've already done that. We spent some time working with those already. The 7 properties where you add the exponents, subtract the powers, distribute powers, all those fun things. 0 exponent property, and then the negative exponent property. But here the exponents are just going to be rational, which remember means that they're going to have a fraction or something written as a fraction. So we work them the same way. There's really nothing's going to change here. The one thing we're going to do a little different though is that we are going to give the exact answer in both rational exponents, so that's kind of your fraction powers, and we're going to give it an nth root, which is again that radical notation where you might have any root. So radical and nth root really kind of mean the same thing to us. And let's see what we can do here. We got 5 examples. Take a quick look at them. So right here we're trying to multiply 6 to the 1/2 power times 6 to the 1/3 power, and when we do that we keep the base the same, so the base is going to stay 6. But then when we're multiplying, we add exponents. So 6 to the 1/2 plus 1/3 power, which is going to give me 6 to the, if you want to use your calculator, you can. Just type in 1/2, add the 1/3. Make sure you put those in parentheses. And you'll get some decimal, and it's just math, enter, enter. And you get 5/6 power. So if we add our 1/2, and our 1/3, we get 5/6. So that right there is the rational exponent value. That's the fraction power. And then we want to convert that into the nth root notation, which remember the denominator power is what the index of the root becomes. So we're going to have the 6th root of our base number 6. And then that's all going to get raised up to the 5th power. The numerator exponent is the power that goes on the whole thing there. All right, and then the last thing we want to do is just come up with a decimal approximation. So go over to our calculator here. It's just 6 to the 5/6 power. I always like to type in the rational exponent answer, but it's 6 to the, and then I have 5/6 right there, so I'm just going to hit second answer and put that in there. So 6 to the power of 5/6, and we know that this being less than 1 should shrink this for us a little bit, but it's going to be 4.45 as our decimal approximation, 4.45. Okay, and there we go. We got all 3 answers: the rational exponent, the nth root, okay, also called the radical notation, and then the decimal approximation. So let's take a look at the next one here. This one does, let's change this here. Let's put this power of 2 on the outside of that bracket, and then see what we can do. If we look at this, we really can't multiply this stuff together on the inside. They don't have the same base. The powers aren't the same, so we can't work the property in reverse there. But what we can do is we can maybe hopefully reduce this. This is saying what number, when multiplied by itself 3 times, equals 27. This is the same thing, remember, as a cubed root of 27. So if we look at maybe just breaking that down, we hopefully can get that to happen. And it looks like the cubed root of 27, so 27 to the 1/3 power, is just 3. Okay, so I recognize that as being a perfect cube, and for the 1/3 power, remember, it just means the cubed root, so that actually equals just 3. And then we're going to multiply that with 6 to the 1/4, which not a lot of simplifying we can do there. I don't recognize 6 as being a perfect fourths by any means, so we'll go ahead and just keep that as 6 to the 1/4 for now, but we do have a product inside here. These 2 things are being multiplied together, which means we can go ahead and distribute that power of 2 to both parts of that product. So we'll end up getting 3 squared times 6 to the 1/4 squared. All right. If we keep going here, simplifying, 3 squared is actually 9, and then here we have a power raised up to another power, and that's a 1/4 times 2. So when we have a power raised to a power, remember we multiply them together, so 2 times 1/4. Anytime you multiply something by 2, you're obviously just going to double the denominator. I'm sorry, double the numerator there, my apologies. So you times the top by 2 and the bottom by just gets multiplied by 1, so we get 2/4, which does reduce down to our 1/2. So we get 6 to the 1/2 power. And that right there is actually the rational exponent answer. It looks a little weird, probably foreign to us. We haven't seen that one too much. But if we think about putting this into the nth root notation, this actually just becomes 9. The 1/2 power is the same thing as the square root, so this is like 9 square roots of 6. That we've seen, we've worked with that quite a bit. But in the rational exponent notation here, it does look a little funny probably. But let's go ahead and type that in. We'll get 9 the square root of 6, 9 times the square root of 6 here, hit enter, and we'll get about 22. We know the square root of 6 is, it's between 4 and 9, so it's going to be between 2 and 3, and then we're going to times that by 2. So yeah, we're talking, 18 to 27, which 22 falls in that area pretty quickly. So we'll get about 22.05 as a decimal approximation. All three answers we're looking for. Okay, let's move on to number 3 here. We have 6 divided by 6 to the 3/4. So here's a case where we do have the like base terms again. Remember, 6 is really 6 to the first power. So we have the like bases, and when we have like bases and they're being divided, we subtract the powers. So this becomes 6 to the 1 minus 3/4. Okay. And if we think about that, we could also cancel. It's kind of tough to cancel fractions sometimes, but the 3/4 power would cancel out 3/4 of the 1 on top, and hopefully we know that that's just going to leave us with a 1/4. We're taking 3/4 out of 1, or we can just do the subtraction there. But remember, make sure you know both. That you can cancel this out. But the subtraction is kind of key there, especially when you get a fraction on top and bottom. It's a little tougher to maybe do that cancellation technique. But really, 1 is just 4/4. Subtract 3/4, and we would get our 1/4, right? So 0.25, math, enter there to turn it back into a fraction. So we end up getting 6 to the 1/4 power. And there's your rational exponents. Turning that into an nth root here, or the radical notation, it's the 1/4 power is the same thing as a 4th root, so we get the 4th root of 6. And then let's get the decimal approximation for our final answer here. It's just 6 to the 1/4. And again, preferably, I'd type it in as a rational exponent. You can go into, remember, math and get down to the xth root button there. If you want to do the 4th root, we got to type the 4 first, and then the xth root of 6. And we know that's less than 1. Okay, so that power is going to shrink our value here. It gets us about 1.57. So 1.57. Sorry about that. So 1.57. Okay. Take a look at number 4. There it is. There's our 3 answers on that one. Number 4, we don't have a whole lot happening here, but we do see maybe that these both have the same power. And when they have the same power, it's kind of like this scenario where maybe we distributed it to both. So we can actually probably undistribute that from both terms. So let's see. We could kind of undistribute a power of 3, kind of running that product to a power property in reverse, and just make this 4 times 2 cubed. Okay, and again, that does, if we can distribute that back in, we can see we get that exact expression there. That's still raised to the negative 1/3 power. And then simplify that by 1, we can multiply the 4 times 2 and just get 8 here. And then the power to the power, we multiply those together. And this is a case where you're multiplying things that are reciprocals. And whenever you do that, you should get 1. So 3 times negative 1/3 is going to give me negative 1. Then that brought in the negative exponent property for us, which, if we remember, that means flip this value over and then write it with a positive power. So 8 to the negative first is really 8 to the positive first, 1/8 to the positive first power, which anything to the first power, remember, we don't need to write. So there is kind of all 3 answers in one right there, other than maybe the decimal approximation. Just take your 1 and divide by 8. We get about 0.125 for that one. All right, so there we go. There's example 4, kind of using that property in kind of the lesser known or lesser used way, but still very valid. Remember, those properties go both directions. Let's try one more here. We got 18 to the 1/4 divided by 9 to the 1/4, so we can't subtract those powers because they are not the same base term there. But I think we can do something similar to what we did on the last one, and that's just pull that power of 1/4 out. Okay, since it's on both the top and the bottom, we can just make it 18 over 9 to the 1/4. Okay, that's still all getting cubed. And then we can kind of reduce. So very similar, just using the quotient property here rather than the product property. But the 18 over 9 just becomes 2. And then we can multiply our powers together. And 3 times 1/4 is 3/4. Okay, top times top, bottom times bottom. And then there's your rational exponent answer. Your nth root, the denominator is 4 of the power, so that's going to be the index, and then the base is 2, and now the numerator power you can put inside here as well, or you can wrap it to the outside. All right, and then let's type that into the calculator. Let's see, we get 2 to the 3/4. And we'll hit enter there, and we'll get about 1.68. So 1.68 as the decimal approximation. Okay, thanks for watching.